Welcome to our channel name as Code with Toby. So in this video we are building a RAG application. So RAG stands for Retrieval Augmentation Generation. So first of all, why we need RAG? If you have used any large language model, then you know they are not trained on your personal or latest data. To work on that type of data, we can use RAG. So, if you want an large language model to answer your query, which is on something in which the large language model is not trained, then you have to provide some information which are relevant to that query. Then we will send our query and the relevant information in a prompt to that LLM to generate the answer. So, to build the RAG application, we are using LangChain, which is a framework which we use when we need to work with context-aware application with the large language model. And we are using ChromaDB, which is a vector store where we are storing our data in a vector form. And for embedding model, we are using ByBusy-based English version 1.5, which is an embedding model. So why we need an embedding model? Because our data will be in characteristic format and we want it to be in vector format because most of the machine learning models only work with numerical data. So that's why we need an embedding model to convert the characteristic data to a vector format. And apart from that, we are using a WizardCoder model as an open source large language model. So before moving towards the code, let's first briefly understand the flow of our RAG application. So we have some data which is in PDF format. So to work on that data, we have to first extract the data from that PDF. So we have the data in raw format and we are extracting that data. We are using PyPDF for that. It is a library which is in LangChain. So after extracting that data, we are splitting that data into chunks. So there are two reasons for that. The first is we only want to pass the relevant information to the LLM. We don't want to pass the irrelevant information to the LLM. And the second reason, all the large language model have some token limit. So that's why we can't just pass all the data to the LLM. We will be passing only the relevant information to the LLM. So after splitting the data into chunks, we are converting the characteristic data into a vector format using an embedding model. And after that, we are storing those vector in a vector store. In our case, we are using ChromaDB. And after that, here come the second part where user will have some query. We will pass the query to the LLM with the relevant data, which we will find using some retrievers. In our case, we are using multiple retrievers such as Cosine Similarity Retriever and the Maximum Marginal Rate Retriever. So after retrieving the relevant data from the vector store based on the query, we will pass the query along with relevant data to the LLM to generate the response. Let's move towards the code. Let's start by installing Python in our system. So open your browser, search Python, go to their official website. Here you can see the latest version of Python is 3.13.1, but you won't install it because there will always be some libraries which are not compatible with the latest version of Python. Click on this Windows. We will install a bit older version. Let's go with 3.12.5. Click on this Windows installer. After the download is complete, open this file. check both of these boxes because we also want to add our Python part to the environment variable. Go to this customize installation, check all the boxes. If they are not checked, click on next, check the first one, click install. Now wait for the installation. Now installation is done. Click on the close your browser. Now let's first open the terminal. Check if the Python is installed correctly or not. So as you can see, the Python is correctly installed. And the version which I am using for this project is 3.12.5, and make sure you are using the same version which I am using so that you don't get any other error while working on this reg application. Let's check the pip version also. So yeah, it's correctly installed. If you are using some other version and want to change your Python version, just go to the environment variable, click on the environment variables, click on this path, edit. If you have multiple Python version, just move the version of Python which you want to use to the upside. So after that, you can click on OK, OK, and OK. Let's start work on our reg application by creating a new folder. Let's name it as a reg. Open this folder in terminal. Now we will create a virtual environment, and all of our work of reg application we will do that in virtual environment. Why we need a virtual environment? Because when we work with this type of application, most of the time we have to do the compatible check between the libraries, like which version of a particular library is compatible with the version of another library, and we don't want to change our system setting because of that. So let's start by creating a virtual environment. Python env, and now we have to give the path where we want to create the virtual environment. Let's name it as a reg application. It will take some time. Now our virtual environment is created. Go to this reg application folder. Now let's activate the virtual environment. It can be done by using this command, scripts activate. This will work only when you are in PowerShell, Windows PowerShell. For CMD and for base it will be different. So go to your browser, search Python virtual environment, go to their official documentation. So here we can see the command to create the virtual environment, and if you go a little below, here we can see the commands to activate the virtual environment for PowerShell, which we used, and for command for base. Now whichever shell you are using, you can check here the command to activate the virtual environment. So now let's go back to the our PowerShell. So if we enter now, we will get an error that it cannot be loaded because the running scripts is disabled on this system. So we have to first enable this to run this. So open the terminal as an administrator. Now here type this command to activate the running scripts: set execution policy. Again type execution policy, then type remote sign. It will enable the scripts. So now close this and again try this command. Now as we can see, we can activate our virtual environment. Let's first clear. Now the first thing which you will do is to install the Jupyter Lab. So pip install Jupyter. It will take some time to install all the dependent libraries, and as we can see, Jupyter is successfully installed in our virtual environment. So let's open this in our browser by typing Jupyter Lab. This command will open the Jupyter Lab in your browser. Let's first create a folder. Let's name it as a client. Go inside the folder and create a new Python notebook there. We'll rename it as a vector formation. Now let's first download some libraries. Let's create a new terminal. Now let's first activate the virtual environment here. And activate. Now let's first install LangChain. LangChain community and PyPDF. So it successfully installed. Now let's go back to vector formation. Now to start working on our RAG application, we need some data. I have one file, data.pdf. It contained the data of 100 books. For each book, it have name, genre, year of publish, and the author name. So the extension of this file is .pdf. So we need a PyPDF loader to load the data from this PDF. Let's first copy the data file in our client folder. So to load the data from this data.pdf, we will be using PyPDF loader. You will import this from LangChain community .document loader, import PyPDF loader. So this is especially for PDF. If you have a file with different extension, go to your browser, search LangChain, go to their official website, go to the LangChain documentation, go to integration, click on document loaders. Here you can find loaders for web pages, for PDF, for cloud, for social platform, and for many more. You can check them as you need. So let's go back to our vector format. Now let's first get the path of our data file. Now let's define loader, which we will use for loading this PDF, loading the data from this PDF. Now this PyPDF loader has a functionality called a lazy load. It is asynchronous in nature. It is very useful for handling large PDF efficiently because it don't consume too much memory. Rather than loading everything at once, it loaded chunks one by one. So this function return a list of chunks. So for pages in loader.lazyload. So before that we also have to create an empty list. Now we'll run this loop and we will append every page to these pages. Now if we check for pages and if we run this, it successfully loaded the data from the data.pdf with some metadata. Now as we are done with the loading of the data, we will now move towards the next step, which is to divide this data into smaller chunks. And to do that, we are going to use recursive character text splitter. So we will look into how it works, but before that, let's see how we can use recursive splitter in our code. So it is a library which we can find in LangChain text splitter, import recursive text character text splitter. Now first we have to define text splitter. In this we have to provide two parameters. First one is chunk size. Let's go with 120. And the second is chunk overlap. Let's go with 24. So what is chunk size? So it referred to the maximum number of character allowed in each chunk. So after defining text splitter, let's split our documents based on the chunk size. As we can see, it successfully splitted the document into smaller chunks with the chunk size of 120. Let's see how recursive character text splitter actually work. So in recursive splitter, we have four levels of splitting: primary split, secondary split, tertiary split, and final split. In primary split, it uses primary delimiter, example, line break, or curly braces. So what is a delimiter? A delimiter is a character or a sequence of characters which is used to separate text into smaller parts. So if you look into this example, we have a data of 4 books separated by line break. So by using primary delimiter, which is a line break, we divided into four smaller chunks. So after the primary split, if user defined chunk size is still less than the current chunk size, then it will go to the secondary split. And in secondary split, it uses secondary delimiter example dot. There are many more delimiter which you can find on the official documentation. And after the secondary split, if the chunk size, if the user defined chunk size is still less than the current chunk size, then it will go to the tertiary split where it uses space as a delimiter, and after that it goes to the final split where it just uses split at character level. Now as we are done with the chunking part where we converted the entire document into small chunks, we can now move towards the embedding part. So for that, let's first go to Hugging Face platform, click on their official website, click on Spaces, search tab leaderboard, click on this. It will take some time to load. Here you can find the ranking of all public model and on which language they are trained on: English, Chinese, French, Polish, Russian, and how they perform on different matrices. And we are also provided with the max tokens of each embedding model. In our case, the embedding model which we are using is by BZ. Yeah, this one. By BZ base English version 1.5. So if you click this, here is the entire detail of this model. You can check that out. So we are using this model. So copy the name of this model. Let's first define our embedding model name. Now to use this model, we have to first import Hugging Face embedding from LangChain community. So from LangChain community, embedding import Hugging Face BZ embedding. Now we have to define our embedding model. So embedding model Hugging Face BZ embedding. In this we have to provide the name of our embedding model. So model name, embedding model name. And we also provide one extra parameter which is encode quarks. In this we will provide normalize embedding to true. So what will this normalize embedding does? It will tell model to use cosine similarity to convert the characteristic data into vector format. So we have to also provide this parameter in our embedding model. So now if we run this, we have to also provide the comma. Now we are getting one error in which we have to first install sentence transformer to use this. So let's install this. It will take some time. So sentence transformer is successfully installed. So let's go back to vector formation and run this again. So it will take some time because it's downloading that entire BG based model locally. It is of size 438 MB, so it will take some time. So as you can see, it successfully downloaded that model locally. So we can use this embedding model now in our vector database. In our case, we are using ChromaDB for that. So before moving towards the next step, let's first see why we need this embedding. So the overall process till now was to load the data, to convert the entire document into small chunks, then using an embedding model, we are converting that characteristic data into a vector format. Then later on, we will also look how we will store those vector in our vector database. So why we need vector embedding? So the first reason is that a vector embedding is a numerical representation of content in a form that AI ML model can process and understand. And the second reason is to fast retrieve of relevant data. Suppose if we have used characteristic data, then to find relevant data, we have to use some string search algorithm, and it will be very slow comparison to finding the relevant data using cosine similarity and MMR. MMR is maximal marginal rate. And the third reason is definitely we can use cosine similarity rule and maximal marginal rate to find the relevant data if we are using vector database. As we are done with defining embedding model, let's define our vector store, which is ChromaDB. So before defining that, let's first install ChromaDB. So pip install ChromaDB. If you are also getting this error while installing ChromaDB in your system, then you have to first install Visual CPP build tools. And to do that, let's first go to this website. Here we have to first install this build tools. So after download is complete, open this file. It will install Visual Studio for us. Now after your Visual Studio build tools open, click on this first one, desktop development with C++. After selecting this one, click on install. It will take time because it is of 2 GB. So wait for it. So after build tools installation is done, click OK. Close this. Go to your Jupyter Lab. Again try to install ChromaDB. So as we can see, after installing Visual Studio build tools for C++, we can successfully install ChromaDB. So go back to your vector formation. Now let's define our vector store. So for that, we need to first import chroma from LangChain vector store. From LangChain vector store, import chroma. So after this, we will define our vector store. Chroma from documents. In this, we have to provide three fields. The first one is document. In our case, it is splitted pages. Then the embedding, and the directory where we want to store this vector. Let's name it as a vector db. Let's run this. It will take some time. So as you can see, our vector db is successfully created. Now let's check if our vector is correctly stored or not by using a retriever. So let's define a retriever first. So retriever vector store dot as retriever. In this we have to provide a parameter called search type, and here we will provide MMR, maximal marginal rate. Now it will use maximal marginal to find the relevant document based on our query. So let's first run this and let's invoke this retriever with the query. So the query will be the author name. So let's see what it returned based on this query. So as we can see, it returned the most relevant data, in which the first data, the book, was written by Harper Lee, and that's what we wanted. So yeah, our vector store is successfully created. Now as we are done with the creation of our vector store, we can move towards the next step, which is to create the user interface where user can enter his query, and using that query we will retrieve the relevant document and then pass the relevant document with the query in a prompt to a large language model to generate the response. And the response which we will get from the large language model, we will show that to the user. So let's first create a new file, new Python file. So click on this plus, click on this Python file. Let's name it as a app. So to create the user interface, we are going to use Streamlit. It is a very easy to use library. So first install the Streamlit. So pip install Streamlit. It will install the Streamlit for you. So after the installation is done, go back to your app.py file and import Streamlit as st. Now to run this app.py file, go back to your terminal, type Streamlit, run, and the path of file which we want to run, client and app.py. It will run the app.py file for us. Go back to your Jupyter. Now let's first create a header, st.header, in which you will write asks me anything. So if you run this again, yeah, so now it's showing us the header. So the first thing which we need is to create a chat box where user can enter his query. So st.chat input, here we will also type ask me anything, and if we run this, we'll get the chat box where user can enter his query. Now we will store this query in a variable called user query. Now we will use this query to retrieve the relevant document from our vector store. So for that we have to first create our retrievers, and to create retrievers we need the embedding model. So let's first create our embedding model, or we can say let's first define our embedding model. So for that we will create a function and we'll name it as a load embedding model. So when we invoke this load embedding model, it will return us the embedding model. So let's first define our embedding model here. We don't need to define, we can just copy from vector formation. So copy this one. Also import the library, and we have to return the embedding model here. Now we have the embedding model, we can define our retrievers. So in our case we are using multiple retrievers. So before defining our retrievers, let's first look how our overall retriever process will look like. So we have a query which user entered, and using an embedding model we are first converting that query into an embedding query, meaning we are converting that query into a vector form so that we can use retrievers with a search type of MMR and search type of cosine similarity to retrieve the relevant documents from our vector store. So after converting that query into an embedding query, we are passing that embedding query to our retrievers. Here we are using two retrievers. One retriever is uses search type of MMR, Maximal Marginal Relevance, and another retriever uses search type of cosine similarity. So in cosine similarity, it's check cosine angle between two vectors to check how close they are, meaning how relevant they are to each other. And in maximal marginal relevance, it returns the most relevant documents by preventing redundant data. So after getting relevant document from both of the retrievers, we are using an ensemble retriever to ensemble the result which we are getting from both of the retrievers. So after ensembling the result which we are getting from both of the retrievers, we are reordering them. So in this step, it will reorder the document based on their relevancy. It will shift the more relevant document either at the beginning or at the ending of the context. So after that, we are passing the context to a prompt along with the query to a large language model to generate the response. Now let's implement our retrievers. So we are using two retrievers. So let's create two functions, def load retriever1, and there will be another function which is for the second retriever. So let's name it as a load retriever 2. So let's first define our retriever 1. So the first thing which we need for retriever is the embedding model. So let's call our embedding function here. Now to use this embedding model in our vector store so that we can use vector store as a retriever, let's define our vector store, which we can define using Chroma. In this we have to provide two parameters. First one is persist directory, where we are providing the path of our vector store. So the path is vector dv. And the second thing which we have to provide is the embedding model. So embedding model. Now we want to use this vector store as a retriever. So retriever vector store as retriever. In this, the first retriever which we want to is will use MMR, Maximal Marginal Relevance. So such type will be MMR. And there will be one additional parameter which we will provide, which is search quarks. So what it will do, the search quarks parameter, it will return only the top k relevant documents. So in our case, we are using 6 as k, so it will return top 6 relevant document. Now we will return this retriever. And similarly, we have to define for retriever 2. So we can just copy this code. The only thing which we have to change is this. Here, rather than using MMR, we are using cosine similarity. So just type similarity. Now we have to ensemble both of this retriever. So let's create another function in which we will name it as a load final retriever. Now when we invoke this load final retriever, it will return as the final retriever. So inside this function, let's first call retriever1 and retriever2. So retriever1, in this we will call load retriever1, and in retriever2 we will call this load retriever2. Now we got both the retrievers. Now the next thing which we have to do is to ensemble the result which we are getting from both the retrievers. So yeah, also we have to import this chroma because we are using here. So from LangChain community dot vector store, we have to import chroma. Now to use the ensemble retriever, let's first go to the LangChain official documentation. So search LangChain ensemble retriever. Click on this first link. In this, we have the document for how to combine result from multiple retriever. So in this case, we can use the ensemble retriever, which uses reciprocal rank fusion algorithm to ensemble the result from multiple retrievers. So you can check this out. You can check this reciprocal rank fusion algorithm by visiting their official documentation. So now to use the ensemble retriever, we have to first import this retriever from langchain.retrievers. And inside this ensemble retriever, there are two parameters which we have to pass. First one is retrievers, the retrievers which we want to use, and the weights which will be assigned to each retriever. So let's call this function also. So the first retriever is retriever 1 and the second retriever is retriever 2. Let's leave the weight as it is. Now we ensemble the result which we are getting from both the retrievers. Now we can reorder the documents based on their relevancy. We are going to use long context reorder. So let's search that also. So LangChain long context reorder. So click on this first result. So this page is about how to reorder retrieved results to mitigate the loss in the middle effect. So to do that, we are going to use long context reorder. It is a document transformer. So by using this, we can reorder the document where the less relevant document will be at the middle of the list and more relevant element will be at the beginning and end of the context. So let's use this. So from LangChain community.document transformer, we can import this long context reorder, and to use this we have to first define it. Now because we are going to use this reordering dynamically based on our query, so for that we have to use another function called contextual compression retriever. So let's search that also. LangChain contextual compressor LangChain contextual compression retriever. So if you click on this first link, this page is about how to retrieve with contextual compression. Now to use this contextual compression, we will need two things, a base retriever and a document compressor. So for base retriever, we have this Ensemble Retriever, and for compressor, for document compressor, we are going to use this long context reorder document transformer inside a pipeline, inside a document compressor pipeline to use as a document compressor in contextual compression. So let's first see how to define this contextual compression. So to use this contextual compression retriever, we have to import this from LangChain.retrievers. So let's first copy this. And inside this contextual compression retriever, we have to define two things, base compressor and the base retriever. So let's just copy this. So in base retriever, we are using this ensemble retriever. And for base compressor, we have to further define another thing, which is a document compressor pipeline here. So here we have a document compressor pipeline which we can use to easily combine multiple compressor in a sequence. So how to use this document compressor pipeline? In this we have to import this from LangChain.retrievers.document compressor, and to use this we have to define transformer. So for transformer, in our case we are using long context reorder. So just copy this one. And let's define this. So pipeline compressor, document compressor, inside this we have to define the transformer. So for transformer, we are using this long context reorder, and then we will use this pipeline compressor in our base compressor. And after this, we will just return this compression retriever. Now we have the retriever to retrieve the relevant document from the vector store based on the user query, and we also have the user query. The next thing which we need is the prompt. So to create the prompt, we are going to use the prompt template. So let's first import that. So from LangChain dot prompts, we have to import prompt template. So what is a prompt template? So it helps to translate the user input and parameter to an instruction which we can use to guide the LLM. So let's create a function which will return the prompt. So there, let's name it as a load prompt. Inside this function, let's first create a template which we will use with our prompt template. So this is the template we are going to use with our prompt. So I will also provide this template in the description, but you can also try this by yourself. So in this template, we are first providing an instruction to LLM, in which we are providing you are an assistant for question answering task, and you have to use the following retrieve context. Context is the retrieve document based on the query, and the conversation to answer the latest question in the conversation. Conversation may have multiple questions and answer. So in conversation, you have the latest questions and may also have the chat history, the previous questions. So if you don't know the answer, just say you don't know. Do not provide incorrect answer. So then we are providing context, in which the context is a variable field where we will pass the relevant document based on the query, and then we are providing the conversation, in which we are providing the chat history and the latest question. Then we are asking the LLM to generate your response. So now let's use this template in our prompt template. So prompt template. In this, the first parameter which we have to provide is the template. So template is equal to template, and the second parameter is input variables, in which we have to provide the variables which we are using in our template. So input variables, first one is context and the second is questions. Now we can just return this prompt. Now we are done with the prompt, we are done with the retriever, we are also done with the user query. So the next thing which we need is our LLM model. So to use the large language model, we have to first download it, and in our case we are using WizardCoder model. So let's first go to Hugging Face. So search Hugging Face, click on the first result. Here you can search the block WizardCoder hyphen Python. We are using this one, the block WizardCoder Python 7 billion version 1.0. So if you want to download this model, you can go to this files, And here you can see all the WizardCoder Python model with the 7 billion parameters. So let's first read about this model little bit. So let's go little below. So here in this 7b represents 7 billion parameter, meaning this WizardCoder Python model is trained on 7 billion parameter. There are two other models. One is 13 billion parameter and the other one is 34 billion parameter, meaning they are trained on 13 billion parameter and 34 billion parameter. And even in this 7 billion parameter model, we have different model with the different bits. So what I mean here is, so the first model is Q2K, then Q3KS, then Q3KM, and further on we have till Q8. So Q2 represent, meaning this model uses 2 bits to calculate the answer. And if we use Q4, it uses 4 bit to calculate our answer. And for Q8, it uses 8 bit to calculate our answer. Higher the bit, more accurate the result, but it will require more computational power. So, and also the size of the model will be larger if you use more bit size of model. And we also have provided the max RAM required to run a particular model. For Q2, we required 5.3. So you can check according to your system which model you can use. So, so we will be using this 7 billion Python WizardCoder model with a Q4, meaning it will use 4 bits to calculate the answer. So let's go to the files. Let's first download this. We are downloading this 7 billion WizardCoder Python model with the Q4, meaning it will use 4 bit to calculate the answer. So let's click on this download icon to download it. It will start downloading your model. So after your download is complete, create a new folder here. Let's name it as a models. Move that WizardCoder to this models folder. Now to use this WizardCoder model with our RAG application, we have to use LLamaCpp. So go back to this website, click on this model card, go little below. So there are two ways to use this WizardCoder model. So the first way is to use with LangChain and LLamaCpp Python, and the second way is used to with LangChain and C transformer. So we are going to use this WizardCoder model with LangChain and LLamaCpp Python. So click on this first one. So this page is about how to use LLM models with LlamaCpp and LangChain. So let's first install this using pip. So pip install llama cpp python. Enter. So it will install llama cpp python for you. Let's wait for the installation. So if you also getting this error while installing llama cpp python, which is failed to build installable wheels for some PyProject.yml based project. So to solve this error, let's first read the error. Here it's saying it could not find Git, and because of that it was not able to install llama cpp python. So to solve this error, we have to first install Git. So let's go to your browser, search Git, go to their official website. If you are a Windows user, click on this Windows. If your system is 32-bit, then click on this first link. Otherwise, click on the second one. It will install Git for you. So after installation is complete, click on this file, read the license if you want, and then click on next. Set the path for your gate, click on next, click next, next, click on next, again click on next, 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 and install. It will install Git for you. After Git successfully installed, click on finish. Then to check if Git is successfully installed in your system or not, open your terminal, type git version. It will give us the Git version if it is successfully installed. So as you can see, Git is successfully installed in our system. So let's close this. Now let's try to install LLamaCpp Python again. As we can see, after installing Git, we were successfully able to install LLamaCpp Python. But make sure you have restarted your system before installing LLamaCpp Python. So let's go back to our app.py. Here we will use the LLamaCpp Python to work with our LLM. So let's go back to LLamaCpp. Here to use the LLamaCpp, we have to first import LLamaCpp from LangChain community.llms. So copy this. Now let's create a function def load LLM. It will return us the interface for LLM. So now let's define a variable LLM. Now we will use LLamaCpp. Inside this, we have to first provide the path for our LLM model. So if you go to the official documentation, here you can see that we have to first provide the path for our LLM. So go back to your app.py, type model path, and here pass the path for your WizardCoder model. Now the second parameter which we will use for our LLM is this callback manager, which support token wise streaming. So let's copy this. Make sure you add comma. Now we also have to import this. So to import this, we can import them from LangChain core.callbacks. So let's copy this one. Now we also have to install this LangChain core library. So pip install LangChain core. It will install the LangChain core for you. Now to use this callback manager, we also have to define one additional parameter, which is verbose, and we will assign the value to true. So the next parameter is f16 underscore kv, and we will assign it value to true. So what this parameter say? So f16 means here 16-bit float value, and kv means key value. So this F16 underscore KV says it will use 16-bit float key value caching, which will reduce the memory uses and it will improve the performance. And the next parameter is an GPU layers, and we will assign it value to -1. So what this parameter does, it will load the model layers onto the GPU. So here -1 represent that it will load all the model layers onto the GPU. If we use value to 0, then it will load all the model layers to CPU. So we are using GPU in our case, so -1. Let's set the next parameter, which is nctx, and let's assign its value to 16000. So what will this parameter does? It will set the context length. So a higher the value will allow the model to remember more, but it will increase the RAM uses. And the next parameter is max tokens. Let's assign its value to 500. So what this parameter do is it limits the maximum number of tokens generated in single response. And the next parameter is nbatch. Let's assign its value to 8192. What this parameter do, it defines the number of tokens processed per batch. So higher the value of this, then it will increase the speed, but it will require more memory. So the next parameter is nthreads. Let's assign its value to 40. So it specify the number of CPU threads which we want for computation. So it will increase the speed. And the next parameter is streaming. Let's assign its value to true. So what this parameter do, it enables streaming output, meaning tokens will be generated and returned incrementally. So this parameter is usually used for real-time application. The next parameter which we will be using is temperature. So temperature, let's assign its value to 0.01. So what this parameter do, it control randomness in the output. So a lower value makes responses more focused towards the query, and a higher value increases the randomness. The next parameter is top p. Let's assign its value to 0.95. It is a nucleus sampling parameter, meaning it will tell the model to only consider the top 95% most probable tokens. So by doing that, it reduces less relevant tokens while allowing some diversity. So the next parameter which we are going to use is top k. Let's assign its value to 40. So what does this parameter do? It limits the token selection. So here we are using 40, so it will limit the token selection to top 40 most probable tokens. Now let's move towards the next parameter, which is repeat penalty. So let's assign its value to 1.2. So what this parameter do? It penalize repeated tokens to reduce repetition. So if the value is greater than 1, meaning it discourages the repetition, meaning it will penalize the repetition. So it will reduce the repetitive words. But if the value is less than 1, then it will encourage to repeat the repetitive words. Now let's move towards the next parameter and our final parameter, which is the stop parameter. So here we will assign it the value to triple hash. So what it will do, it will tell model to stop generating tokens if it encounter this sequence of character. So it is very useful for structured outputs. Now we can just return our LLM. Now we have our LLM. So before moving forwards, let's first solve some syntax error which we did. So the first one is the function syntax error. So we have to add the close and open brackets. And also we have to add the comma here also. And the third error which we did is this path error. So here we have to provide the proper path. So let's copy the path of our wizard model and paste here. Similarly, we have to provide the proper path for our vector DB. So it should be client vector DB, and here also it should be client vector DB. Now let's move forward and create a caching for our LLM, for our embedding model, and for our retrievers, and for our prompt. So we can implement caching by Streamlit itself. So to implement caching, type add st.cache resource. Here what it will do, it will create caching for the function itself. So first of all, why we need this caching? Definitely to improve our model response. Suppose, let's example, a user will query something, and to generate the response for that query, we need to load this LLM. So we will call this function load LLM. It will create the LLM for us, and then it will return the LLM. But what if user do multiple query? Then for each query, we have to call this function, and it will create LLM again and again, which will make this call very expensive. So that's why we need this caching here. So let's implement the caching for embedding model and for our retrieval also. Now to implement the caching for prompt, to load the prompt, we can use st.cache data. But actually, we don't even need to implement the caching for our load prompt function, because every time the input will be different. So because the input is different, the output will also be different. And because of that, we don't even need to implement caching here. So let's just remove this. Now we have our prompt. We also have the user query. We also have the retriever and the LLM. Now we need a way to combine all of them together. And for that, we are going to use Retrieval QA. So to use the Retrieval QA, we can import Retrieval QA from LangChain dot chains, and here we can import Retrieval QA. So what is Retrieval QA? So it is used to build question answering system in which it will retrieve the relevant document from vector store, then it will pass those relevant document along with the query, user query in a prompt to the LLM to generate the response. So let's create a function which will return the instance of this retrieval QA. So def chains of QA, in which we have to first load our LLM, prompt, and the retriever. So LLM load LLM, and then the prompt load prompt, and then the retriever load retriever, final retriever. Now we need to use all of them together in retrieval QA. So we will create an instance of retrieval QA. So from chain type, it will create the instance of retrieval QA. So in this, the first parameter which we will pass is the LLM. So let's pass this. And the second parameter is the chain type. So here chain type is stuff. So this chain type is the simplest one, where it will combine all the retrieve relevant document into single context, and then it will pass that context to the LLM. The next parameter which we will pass is the retriever. So pass the retriever, and the next parameter is verbose, which will pass as a true. So what does this parameter will do? It will logs all the internal details about how the chain, but how this chain process the data, including retrieving the data, and also how it manages the input and output at each step, and also the execution time. Let's move towards the next parameter, which is our prompt. So to pass the prompt, we have to use chain type quarks, and inside this we have to pass our prompt. So prompt, and we also have to pass the verbose here to true. Now we can just return the instance of this chain. So return chains. So let's create a variable where we will store the instance of this chain. So chains of Q&A. Let's also implement a session state, where we will create a list variable. So if conversation not in st.session state, then we will create a conversation variable list in our session state. So st.session state conversion conversations will create it as a empty list. So what it will do, it will store all the conversation between the user and the bot in a single session state. So why we need this? There are two reasons for that. So the first reason is to show the conversation which user did with the bot. If we don't store the conversation somewhere, then how we will show the conversation to the user? That's why we need to store it somewhere. And the second reason, we will pass the previous conversation of the user with the new query which he did to the LLM. And to do that, we need to store the previous conversation in our session state. Now we created an empty list name as conversation in our session state. So now we have the user input. So we will first check if user did some query or not. So if user query, then we will call a function create answer, or we can say generate answer, in which we will pass this user query. Now let's create this function there generate answer, in which we are passing this user query. So let's say it is a question. We will first check if question is none or not. If it is none, then we will just return. Otherwise, we will move forward, and then we will get the size of this conversation list. So, and let's name it as a sj length of st session state dot conversations. After assigning the length of this conversation list to sj, we will first check if it is greater than 0 or not. If it is greater than 0, then we will insert the previous two or three conversation in our question. So for that, let's first create a variable empty string. So let's say it is a final query, and in this final query we will first insert the previous two conversation, then we will insert this new question. So for entries in st dot session state dot conversations, in this we will use the previous two conversations. So -2, and so we will separate each conversation by using curly braces. So let's first add the curly braces, final query plus open curly braces, then we use a line break. Then we will add an identifier which will tell the LLM if the sentence is written by a human or the AI. So let's add that. So final query plus human colon and then a line break. Then we will add the sentence which is written by human. So final query plus entries. So in entries, Entries here represent each conversation between the human and the AI, or we can say between the user and the bot. So entries will contain two values for human and for the AI. So inside this entries, we want a value which key is Cosine. Then we'll again add a line break. Then we will add the response which was generated by the AI for this particular question. So final query plus, let's first add the identifier. So let's say it is a AI, and then we'll again add one line break. Then the final query here in entries, we want a value which was generated by AI. So let's say it as an answer and the line break. And after this we will add the close curly bracket, and then we will add the line break. Now after this for loop we will also add the latest question which was asked by the user. So final query plus, first we have to add the identifier human, then a line break, then we will add the latest question, and then we will generate the response using this instance of chains by passing this final query. So let's say it is a AI response using chains. We will invoke the instance and we will pass this final query as query. And then we will store this AI response and the latest question in our session state. So st session state conversations, we append first, we will add the question, the latest question. So question, then we will add the response generated for this question. So answer AI response. Then after generating the answer, we will display the answer. So let's create a separate function for that. So let's create a function and we'll name it as a display answer, which will display all the conversation which a user did with the bot. So for entries in st.sessionState.conversations, we will print each conversation. So let's also add an identifier. So with st.chatMessage, here we will add it as a human. Then we will display the query asked by the user. So st dot write, here we will write entries. Using entries we will write the question asked by the user. So question. Now we will also write the response generated by our AI. So st.getMessage AI. We added the identifier as AI, and here we will add the response generated by the AI. Now let's also add one spinner here, a loading spinner, which will run till we are generating our answer using the user query. So with st.spinner we are, let's name it as a generating, and we will run this till we are generating the answer. Now if we run this, so Streamlit run client app.py, so we are getting one error. Okay, so we have to also add the double quotes here. So in end st.chat message we have to add the double quotes. Save this and reload this again. So here is it's first loading the LLM, then is loading the final retriever. Because we use the caching here, it will load only for the first time. So we are getting one another array. So chroma got an keyword argument embedding. Okay. So here it is not just embedding, here it is embedding function. Now if we save this and reload this page again. Okay, spelling is incorrect. It is function. Now reload this again. Now, now it's successfully loaded all the LLM and the retrievers. We can query now something. Let's run the query book written by Harper Lee. So if we enter this, it will generate the response for us. And if you want to see the log, we can go to the terminal, and here we can see the prompt it using to generate the response. So in the context, it retrieve the relevant document which are based on this query, which are relevant to this query. So let's see what it generate. So it's generating, I don't know the answer to your question. So what can be the reason for it's not generating our answer? So if you look closely to the context it retrieve from vector store, here we can see that it did return the book which was written by Harper Lee. So even then it was not able to answer. The reason was because the model which we are using is trained on 7 billion parameter. It is not that good model. So but if we still want this model to work, let's input another query which is check again. So because we are also storing the previous conversation, we can ask a follow-up question to the LLM to generate our answer. So check again. If we type check again, here is not using the previous conversation. Let's see why is that. So if we go to, okay, so here it is conversation. It should be conversation. So remove the S. Now save this again. And also we are getting response like this. We don't want response like this. We just want the result. So for that, rather than using invoke, use run. And if we save this and run this again, now let's again type the query book written by Harper Lee. So if we go back to our terminal, here it retrieved the relevant document based on the user query. Here you can see it retrieved the book which was written by author Harper Lee. Now we only getting the answer. So but still is returning I don't know the answer to your question. So we can again say check again. Here now it's using previous conversation. So let's see what it, yeah, so now it's returning the book name which was written by Harper Lee. So as you can see is now working. But if you want to improve the accuracy of the response, then either you can try a better model. Better model means you can try the WizardCoder model with the 13 billion parameter or the 34 billion parameter one, or we can also improve our prompt. So in this prompt, we didn't provide the information that we are providing you data regarding books. So you have following pieces of retrieve context which contain the data for books. Or you can also use different type of retrievals here. You can just go to the LangChain official documentation to learn about retrievers. There are many more retrievers there. So you can also try them to improve your response, to improve the accuracy of the response. And yeah, also you can try this also, where you can change this parameter for the LLM to generate a better response. Our basic reg application is now completed. So if you have learned something new from this video, then please like this video